This is the start of Chapter 4. Chapter 4 is all about integration. And in section 4.1, we are going to talk about antiderivatives and the power rule. So all throughout kind of chapters 2 and 3, we've been talking about finding derivatives. So if we're given f of x equals x to the fourth, we've found the derivative. F prime of x is equal to 4x cubed. What we're going to be doing is we are going to be given the derivative, and now we want to go find the function. So think about for a minute, if we are given the derivative and we're given f prime of x is equal to x squared. We need to know what f of x is, or what f of x could be. Well, if I'm taking the derivative, remember when we take the derivative, we subtract 1. So this one here has to be 1 more. This should be x to the third. But if f of x was x to the third, then f prime of x would be 3x squared. So to kind of cancel out that 3 that you would move out front to take the derivative, we need 1/3 here. Notice if I move the 3 out front, 1/3 times 3 cancels as 1, and then subtract 1 from the exponent. The derivative of 1/3 x cubed is x squared. So the antiderivative of x squared is 1/3 x cubed. I want you to think about for a minute, if I have f prime of x is equal to x to the third or x to the fourth, what the antiderivative of each of those would be. So if I want to get x to the third, this one needs to be x to the fourth. This should be 1/4 x to the fourth. Has a derivative of x to the third. 1/5 x to the fifth has a derivative of x to the fourth. These are not the only functions. These are an antiderivative of x squared. But there's other ones as well. F of x could also be 1/3 x cubed plus 4, because the derivative of 4 is 0. The derivative of this is also x squared. Or f of x could be 1/3 x cubed minus 702, or 1/3 x cubed plus pi. Any constant here would have a derivative of 0. So what we do is we say that f of x is equal to 1/3 x cubed plus c, plus any constant. And that will bring us to the power rule. The power rule for integrals. First of all, the way we write this is it looks like this. The integral of x squared dx. So this is the same thing as asking what functions have a derivative of x squared. This is read as the integral of x squared dx. This dx is called the integration constant, or the variable of integration. And it's just telling us what we're integrating with respect to. So this is telling us that our variable is x. So the integral of x squared dx is 1/3 x cubed plus c. The power rule for integrals says if we integrate x to the n, that's an n, integral of x to the n dx. Notice to get here, I add 1 to the exponent, and I divide by this new thing. So I am going to add 1 to the exponent and divide by this, and then plus some constant. That is the power rule for integrals. This works for almost every n value. There's one n value that it does not work for. N cannot be -1, because if n were -1, we would be dividing by 0. So the power rule works for all n values except for -1. If n is -1, there's another rule that we'll learn later. So let's take a look at example 1. Example 1 asks us to integrate 3x to the 8th minus 4x squared plus 2x minus 5 over x squared plus root x dx. That's a bad integral symbol. The integral of 3x to the 8th minus 4x squared plus 2x minus 5 over x squared plus root x. This is not all written as powers right now. These first three terms are, but this one is not. The x squared on the bottom, root x. So let's go ahead and rewrite this before we integrate. So 3x to the 8th, that's okay. 4x squared is okay, plus 2x. Let's write this as 5x to the -2nd, and root x as x to the 1/2. And now we can use the power rule. The power rule says if I'm integrating, I add 1 to the exponent, and I divide by that thing. So 3, I'm dividing by 9. Add 1 to the exponent, and divide by that thing. The 4 was already there, I'm dividing by 3. Add 1 to the exponent, divide by that. Add 1 to the exponent, -2 plus 1 is -1. Divide by -1. 5 divided by -1. 1/2 plus 1 is 1 1/2. And then when I divide by 3/2, dividing by 3/2 is the same as multiplying by its reciprocal. So if you divide by a fraction, you can just multiply by the reciprocal, so make that 2/3. Anytime you integrate, we are going to tack on a plus c. We could have some constant, and then reduce. 1/3 x to the 9th minus 4/3 x cubed plus 1x squared. Negative divided by negative is plus 5. X to the -1st can go on the bottom. Plus 2/3 x to the 3/2 plus c. You can always check these by taking the derivative of this. If you take the derivative of this, you should get right back to where we started right here. 9 divided by 3 is 3, subtract 1 from the exponent, and so on. 4/3 times 3 is 4, subtract 1 from the exponent. Example 2 asks for the integral of x squared times x cubed minus 1 over x dx. Just like derivatives, we cannot just take the integral of this and the integral of this and multiply them together. We do not, at least not yet, have a product rule or a quotient rule or a chain rule. So the only way we can do one like this is to distribute so that I do have powers and can use the power rule. X squared times x to the 3rd. When we multiply, we add exponents. X squared times 1 over x is x. And then we can use the power rule. Don't forget your plus c. Example 3 asks for the integral of x plus 1 over root x dx. I'm going to rewrite that root x as x to the 1/2. Divide. When we divide, we subtract exponents. So we have x to the 1/2 plus 1 divided by root x is x to the negative 1/2. And integrate. Add 1 to the exponent. Divide by 3/2. Same thing as multiplying by 2/3. Add 1 to the exponent. Divide by 1/2. Same as multiplying by 2/1. Back in chapter 2, we learned that the derivative of sine x is cosine x. Therefore, the inverse of that would say the integral of cosine x dx is sine x plus c. Derivative of sine is cosine, therefore the antiderivative of cosine is sine. We know the derivative of cosine is negative sine x. Therefore, the integral of sine x is negative cosine x. And then the other trig rules hold as well. The other one you should know, derivative of tangent x is secant squared. So the integral of secant squared is tangent. And then one more example, where are we at? Example 4. Example 4. Sometimes we're given an initial condition so that we can figure out what C is. So here we are given f prime of x is equal to 3x squared minus 4x plus 1. And we know f of 2 is 4. We need to find f of x. So find the function that has a derivative of this and passes through the point 2, 4. So to go from the derivative to the function, we need to find the antiderivative. We need to integrate. So we are going to integrate f prime of x. Integrate. When you integrate, you add 1 to the exponent, and then you divide by that same thing. Add 1 to the exponent, divide by that. Here, what has a derivative of 1? 1x has a derivative of 1. So we get f of x is equal to x cubed minus 2x squared plus x plus c. This is called the general solution. We don't want a general solution. We want the solution that goes through just this point. So we can plug in 2 for x and 4 for f of x and solve for c. So I plugged in 2 for my x's, 2 cubed is 8, 2 squared is 4, times negative 2 is minus 8, 2 in for my x plus c. I put 4 in for f of x, and I get c equals 2. So the answer is f of x equals x cubed minus 2x squared plus x plus c, but c is 2. This is called the specific solution, which is what we're looking for in this problem. That is section 4.1 on antiderivatives and integration.